Yeah. Right. Guys, we'll continue now. So, yesterday we were looking at solving and sketch. Guys, please. Yesterday we were looking at solving and sketching cubics. So I think, what's next now? Is it one linear and one quadratic? Huh? I can do it in the tutorial. Which was there one question in particular? Which one? Okay, 2b was it? Okay, we'll do 2b before we start then, since people are eager to see it. Okay, so from the homework 2b was 24x cubed minus 83x squared plus 79x minus 18 greater than 0. Did this have a root? Easy to find? And what was it? The three roots? Well, what was the one that you found by guessing? 2, okay. So you had x equals 2, so that means x minus 2 is a factor. And when you divided, did the quadratic have factors? Yeah, okay, so what were those factors? The root, yeah, so that would be 3x minus 1, yeah? So 9 over 8 was the other one, was it? Okay, so if I draw this here very roughly, we have a 2 here, a 1 over 3, oh, they're all positive, are they? And then a 9 over 8, which is going to be, let me just write it down. So 9 over 8 will be like here, come on. And then 2 is like here. Yeah. So when I draw the cubic, I'll get something that goes up, down, and up. And I wanted, great. Well, this is the y. And I want it to be positive. So here is when the y is positive. And here is when the y is positive. Here the y is negative. And here the y is negative. So I only care about this part and everything out here. So that means the x has to be bigger than 1 over 3, but smaller than 9 over 8. Or just bigger than 2.
I put that y-intercept, was that wrong?
Yeah. What do you mean you put the y-intercept? You used it?
Yeah, I used it.
No need to use it. You shouldn't be using it. So it's like this. Write this one down, and then we'll have a look at the new topic. So, run. Did you show up for the test yesterday?
Yeah.
At what time?
Early.
Where are you?
I know.
What time? Give me the number. Don't you?
I saw him inside.
Oh no, I believe that he was there. I'm just curious at the time. So I saw a very angry principal yesterday looking for missing students. You weren't one of them, were you?
No.
Are you sure?
Yeah.
Oh, all right, okay. Must have been someone else then. Okay. Did you write that down? Yeah. Okay, just let me get my calculator and then we'll have a look at the next lesson. Here's my calculator. There it is. Right. Okay, you have that now? Yeah? Okay, we'll continue then. There we go. Right, next lesson, so. There's nothing. Yeah, there's not a lot to do in this next lesson, so I think I'll do 2 examples and then I'll give you time to work on the homework in class. And I want to have a chance, I haven't really had a chance to look at everyone's notebook, so I wanted to see how people are keeping their notes and things. So, previously we saw how to solve problems like this, where you have 2 lines and you want to find where they meet. Okay? And we have a few methods for this. We had substitution, elimination, what else do we have? Graphical, yeah, Gaussian, yeah. So we have a few methods here. Now what we're going to look at today, as an example, is how to solve a situation where you have 1 linear and 1 quadratic. Let me just make sure the first one has an answer. Yeah. So we'll do some examples. We'll say, for example, y equals x minus 1 and y equals x squared minus 4x minus 1. So this is all about 1 linear and 1 quadratic. This is it. 1 linear and 1 quadratic. So you're solving a system where you have 1 linear equation and 1 quadratic equation. So this is an example. So let's see how to do this. Any ideas actually on how we might be able to solve this?
Y equal to y.
Yeah, what method is that? Like substitution, yeah. So because this is equal to y and this one is equal to y, then they're equal to each other. So that means we can say x minus 1 equals x squared minus 4x minus 1. That means x squared minus 4x minus 1 plus x, nope, wrong, minus x plus 1 equals 0. Yeah, so then we get x squared minus 5x, and this is a 0 at the back. So you can write plus 0 if you want, but you don't need to, equals 0. Now this is very easy to solve because this will just be x taken out, x minus 5. Yeah, so you get x equal to 0 or x equals 5. But of course, that's only the x. We need to get the y as well. We can substitute the y back into either of these equations. In fact, we should really use the first one. It's easier. So, using the first one, we'll get y equals minus 1 and y equals 4. So these are the 2 points then.
Question.
Yep.
Since y equals x minus 1, can we just put y as 0 and just get x equals 1 and just substitute that?
No, because what you're doing now is you're finding the root where it crosses the axis, not where they cross each other. Yeah, come on. Come on. What happened to you? Why are the 2 of you late? Oh, you're late? Oh. I didn't know that. No, why are you late? Huh? The bus?
Yeah.
If you're going to be living here, you're going to have to come up with better excuses than that, okay? The bus exploded. Much more exciting. Right. Now, what we need to do as well is we need to draw this, but just a very rough sketch, okay? Can I scroll down a little bit? Okay. So what exactly is happening here? Why are the two answers? Well, if you draw this, we're saying there's one answer here at, what's that, up here at like 4, 5. And then there's another answer here at, what's that, 0, minus 1. These 2 points, are they on the line?
Yeah.
Yes or no? What do you
Yes,
think?
yeah,
They are on the line. Are they on the quadratic?
of course.
Yeah. Because remember what we're doing, we're finding 2 points
Where's the line?
where they meet. So, by definition, it means it has to be on both of them. You know, if I look at this problem here and I know that they meet here, then I know that this point is on both lines. So I know that both these points are on the line. So therefore the line looks like this. Was it? 5 and 4. Yeah. Oh, well. 5 and 4 then. Okay, so we know that both those points are on the line. So the line will look something like that. But we also know both of them are on the quadratic. And the quadratic looks like this then. Or roughly. So this is the reason why there are 2 solutions, because the line cuts the quadratic twice. Yep. I'll give you one to try. Will there always be 2 solutions?
No.
No. How many solutions could there be?
One.
There could be 1 solution? And could there be no solutions? Yeah, because if you remember that 2 lines always meet except when they're parallel. But of course the quadratic and the line, they don't have to meet, because I could draw it like this, and then they'll never meet. Okay? And what do we call it? I'm sure a few people know this. When it meets only once.
Tangent.
That's called the tangent, yeah.
What do we call the ones I did before?
When it meets twice? I think you can call it a chord.
Chord?
Yeah. But that's not really something you would need for the exam, because, you know, that's the usual situation. They might say, is it a tangent or something?
Or find the line, tangent of the line?
Yeah, or find the tangent of the line, yeah. Although I'm not 100% sure if chord is only used when it's a circle, and if it's for any shape, maybe it's called a secant. I'll have to check it for you. I know for a circle, when it cuts it like this, you call it a chord. Yeah, but I don't know if that's true for any shape. I think it's a different name. Is it a secant? I don't know. I'll have to double check. Okay, can I scroll down? Yeah. Right, try this one for me, let's see. Y equals 3x minus 11 and y equals 3x squared minus 3x minus 8, for example. See what you get from this. And also include a very quick graph, please. A simple little sketch. Yeah, it is. Just checking the dictionary there. It is secant for when it's like this. And then this one is tangent.
So you like in the exam they won't ever say.
I don't think so. It'll just be tangent, I think. Okay, finished?
Yeah.
So
Not yet? Okay. 1 more minute. Finished? Yeah. Okay, that should be enough time. So, using the substitution method, we can say that 3x minus 11 equals 3x squared minus 3x minus 8. That's all fine. So we get 3x squared minus 6x, and what's that? Plus 2? 3. Well, we can divide everything by 3, which I get this. And this is x minus 1, x minus 1. Yeah, so we have only one answer. So this is because it's a tangent here. If x equals 1, y will equal minus 8. By using this one. So when I draw this, yeah.
So when you only get 1 point, it's a tangent.
It's definitely a tangent, yeah. So if this is x and this is y, my point is at, let's see, 1 minus 8, so that'll be like here. Now, we only have 1 point, so just be a little bit careful. The line is going upwards because it's positive slope, so I should draw my line going up. And also the quadratic crosses the axis at minus 8, so that's here. And it's a U shape. So I wanted to touch only once here, so I'll draw. Let's try that again. It's a tangent here. Draw what? That would have been easier when I'm thinking back on it. Okay. Right. Let me show you a different type now. One that's a bit trickier. Can I scroll down? One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think I have 23, there should be 25, so I'm missing Juliana. And who else? Yes. Any special reason? Do we know of? Is there a reason he's absent, do you know of? No. Okay, you know something. You should never play poker. Is there a reason Bahar's not here?
No, because everybody's staring, waiting for an answer. I don't know why you didn't get it.
This is the hand you're playing, is it?
No, I really don't know.
Alright, fine, alright. Okay, continue? Yes? Yes? Okay. Right, so the next one now is a little bit trickier, but you don't need the graph for the next one, but it's still the same idea that there's two solutions. So I'll do this one if you want to write it down, please. We have, for example, 2x minus 11y plus 54 equals 0, and then 4x squared plus xy minus 5y squared equals 0, like this. Now things are a little bit more complicated, because at least in the last question we could simply say y equals, and then that's really it. But we're going to have to do a bit more work here for this one. But it's still the same idea. What we should do is try to get something like x or y in the first one, and then put it into the second one. It doesn't really matter which one you get, if it's x or y. So if you were to take the first one, you can get, yeah, I'll go with 2x. 2x equals 11y minus 54. So then that means that x equals 11 over 2y minus, what's that, 27. That's a y there. Now that I have the, yeah?
What did you do there?
From the left to right here? I just took the, I divided everything by 2, and this came from the first line here, where I just took these two to the right. Yeah.
Why did you divide?
Right, to get x. To get x. I only want x by itself, or y by itself. So now I have x equals.
Yeah.
Yeah. Okay, so next, I put this, substitute it into this one. So now I have 4x squared plus x y minus 5y squared equals 0. Like this. Oh, sorry, and I left out a square here. Yeah? That looks okay. 4x squared plus xy minus 5y squared. So now we have the task of expanding, which is not so bad. This is 121 over 4y squared, and then 270 plus 27, 302. What's 11 times 27? 297. So the next one would be minus 297y, then 27 squared is 729, plus 729, plus 11 over 2y squared minus 27y minus 5y squared equals 0. Next, multiply all of this by 4. So we get 121y squared. Now, 297 times 4, 1188y, and then 729 times 4 is 2916, plus 11 over 2y minus 27y minus 5y squared equals 0. Yeah, I lost my square. Thank you. Yeah, that's okay now. I'll multiply everything by 2. 2, 4, 2 y squared. My 1188 times 2 is 2876 minus 2876y.
1188 times 2.
Yeah, 2876, isn't it? Huh? 2376. What the heck happened there? Right. Minus 2376y, and then the next one, 2916 times 2 is 5832 plus 11y squared minus 54, yeah, minus 10y squared equals 0. Now that's not so bad because now things will start to clean up. So that would be 2, 5, 3, no, and then we have minus 10. So 2, 4, 2, plus 11 minus 10. So now I have 2, 4, 3, y squared, minus 2, 7, 3, 6, minus 54, minus 2, 7, 9, 0, y. And then the last one is just 5, 8, 3, 2, isn't it? There's nothing else to add it to. Is that okay? Did I make a mistake?
Yeah.
I did make a mistake. What was my mistake?
2, 4, 2.
It's not 2, 4, 3? What should it be? 2, 4, 2 plus 11 minus 10. 2, 4.
Yeah, this is right.
That's okay. Oh, the next one's the problem. Minus 2, 3, 7, 6 minus 54. Oh yeah. Yeah. Thank you. Minus 2, 4, 3, 0. Perfect. Okay. Everything is right now. Good. That middle one, sorry, that's 2, 4, 3, 0. Let me just rewrite it again. 2, 4, 3, 0.
Now you can substitute. Just put.
Not yet, no. And if you notice, I think it's pretty clear that all of these can be divided by 243. Yes, I think it's clear to all of us. So if we divide everything by 243, we got y squared. Well, seriously, you can see that the middle one obviously can be divided by 243 because it's 2430, so it's going to be 10 times. And the last one, 5832 divided by 243 is 24. Now that's quite a straightforward quadratic. I think it has factors. 12 and 2? No. 12 and 2? Y minus 12, y minus 2.
Yeah.
That makes 24 and... No, it doesn't. 6 and 4, is it? Minus 6 and minus 4. Great. So we have y equals 6 or y equals 4, and now we can get the x. We remember we have this equation from the very beginning, or nearly at the beginning, for x. X is 11 over 2y minus 27. So if I use that equation here, 11 over 2y minus 27. So if I use 6 for y, then I'll get x is 6. And then if I use, 4, then I'll get minus 5. And this one comes from the start. From this one here. Yeah? Question? Oh yes, I'm sure there's more than one. Which method do you use?
I factorized the quadratic equations there.
Which one now?
Go like
Way up.
the question, yeah. What x this? Yeah.
Very good, yeah.
And then I got something like x minus y equals 0. So
Equal x equals y then. Very good, yeah. If you are so comfortable at factorizing, you can factorize this, then yes, please do it that way. And in fact, I think one of the questions, maybe the more difficult ones, you can only do it this way, by factorizing. That's really good if you can do it by factorizing. For the exam, I think they expect students to do it this way, or by factorizing. And I think in the exam, they'll make the numbers maybe not as big, but the reason I made the numbers so big is because I wanted it to have nice answers. Yeah. So I deliberately picked the numbers so that it all simplify nicely towards the end. Okay, that might not happen in the exam, of course. Okay. Well, we can have a look at it by factorizing as well. Do we have this?
Nothing low.
Yes.
Nothing.
Did you write this down?
Halfway.
Want to move on?
X equal minus 5.
Yeah, that's a minus 5 here. No. Okay, I'm going to move on. Am I waiting for like 2 people? Yeah, moving on. Okay. There is another way to do this, so let me just clean this up a little bit. Right, so the other way to do it is, maybe you can simplify it before you start. So if you were to take this one here, it kind of looks like a quadratic, except instead of having only x squared, there's x squared and y squared in it. But you can still use what you learned in factorizing to try and factorize it. Yeah. So you know that there must be a 4x squared at the start. So maybe that means you have something like 2x and 2x. But of course it could be something else like, what else? 4x and 1x, you know. So it's either going to be 2x and 2x or 4x and 1x. So I'll just write both down and then it should maybe become clear in a minute. Sorry, 1x, which one to choose. Now, sorry, I'm looking at the back here. That's a 5 at the back. Well, that's good because there's only one way you can make 5. That's 1 and 5. So 1 and 5, 1 and 5. Now the other good news is, well, there's a minus here and a plus here. So you must have a plus and a minus, or a minus and a plus. So let's look at what happens if we start using plus and minus. So if I use plus and minus, I only really care about getting the middle piece right because I know the front and the back will work. So if I use it this way, I'll get 10x, minus 10x plus, oh, where's my y? Sorry, I left out my y. I should write my y at the back here. Y, and y, because I want a y squared at the back. Right, so let's try it like this. I'll get minus 10xy plus 2xy, that's minus 8xy. No good. Right, well what about if I try it the other way around? If I try minus here and plus here, I don't think that will work either because that will be 10xy minus 2xy, 8xy. So this is not going to work. It has to be this one. Sorry, that's messy. Let me write that again. That's 1y and that's 5y. Okay, let's try plus and minus. So here that's xy. And this one here. So this isn't going to work either. Did I miss one possibility?
Yeah, it's 4x and then 5y and then x.
Oh, I can have the 5 the other side.
Yeah, 5.
Yeah, okay. So I could have 5 and 1 instead of 1 and 5. Right, so because if I do this, I get xy and minus 20xy. That's not going to work. If I stick the 5 here and make this a 1 instead. Okay, now it's looking like it. Minus 4xy plus 5xy is xy. Right, so after all of that messy business, we can now say that our two equations are 2x minus 11y plus 54 equals 0, and the second one equals 0 is 4x plus 5y and x minus y. Now, what to do next?
X could equal to y.
Yeah, well, you actually have two possibilities to look at. The first possibility is that x equals y, and then the second possibility here is that 4x equals minus 5y, or in other words, that x equals minus 5 over 4y. That's it. So you have two substitution problems. You can take both of these and put them back into this one. So I won't do both. It's not necessary. I'm just going to do one as an example, but you do the same thing for the other one. So I'll just take this one because it's easier and I'm tired. So putting this one in here, x equals y, I get 2x minus 11x plus 54 equals 0. So what's that then? That will be 54 equals 9x. So x equals 6. Now is that what I got earlier? Yeah, and then if x is equal to y, what's y? 6. Which is the same. 6 was the first answer. So obviously this method works. The second answer will end up being minus 5 and 4. Okay.
So in this type of question, they wouldn't tell you to solve this specific
No,
right?
no. The exam will definitely not specify a method for this one. So if you want to factorize it, you can factorize it. And I like this. It's shorter to write, but I suppose the price you pay is you might have to think longer at the start before you can get the factors. But once you do get the factors, then it's a much quicker way to be doing it. Also, of course, you're not guaranteed to have factors as well. This one did have factors, but it won't have factors if the answer will be a surd. Yeah, and unfortunately, there's no way to know at the start if that's going to be the case. But if you spot the factors, then you should use them. Okay, so what I'm going to do is I'm going to give you some questions to do, which you can start now, and then as you're working on them, I just want to have a look at your notebook to see how you've been keeping things. So if you can write these questions down. So for number 1, H and I, for number 1, H and I. Yes. And then for number 2, F and G. In other words, the last two in question 1 and question 2. H and I in number 1 and F and G in number 2. Did you get that? Yeah. Okay, start working on those now, and then I want to have a look at your notebook. Can I close this? Yeah. Okay.
Sir?
Yeah.
Can I have a new copy for the...
I keep forgetting to bring it down. Yeah. Try to remember it next time. Guys, have a look at your notes and homeworks and how you can keep them things. Oh, yeah, okay. Are you going to keep your maths in folders like this?
No, I'm going to rewrite the homework on the book.
Okay. I kind of like when students keep things like this, but if you want to keep it in a hardback, that's fine. But that's okay. Yeah. Are you keeping everything in this? This is all math? Is it?
Yeah.
Right?
Sure.
Yeah, okay. That's good. You're keeping everything in this, is it? Or is this like, this is notebook, is it? Ah, yes, okay, this is like workbook. Okay, that's good. Good job, yeah. Actually, that's good. So you have this is for notes and then this is for practice. Very good, okay. Good, okay. And this is only maths, yeah?
Yeah, my homework. I know to read.
Okay. Okay, yeah, that's good. Yeah, okay, good. Can I close this now, Trick? Let's see what you've been doing.
Pregunta.
You're keeping all your maths in this part?
Yeah.
Yep. Are you keeping everything in this?
That's 2D.
Right, are you keeping everything in this?
Be careful.
Yeah, maybe. Okay. It's only math, isn't it? There, are you keeping everything in this? Only math here? Right, okay. So, are you keeping everything? Okay. That's fine. You're cool with that? Okay, alright. Now, you're keeping everything in this? Okay. Once you know where the different sections are, you need to revise something, so that's most important. That's okay. Yeah. Let's have a look. Is everything being kept in this, or? I see, I've got some marks on this. Oh, okay. But still, we're only in like week 3 or something. That's fine, that's fine. Okay, are you keeping all the maths in this? And some of it's not? Yeah, try to keep things separated. That's okay. That's okay, that's okay. No, don't do that. Good job. Don't mix with other subjects like chemistry and biology, because you'll never get to revise easily. You know, it'll be too unless there's more here, is it? Yeah. Oh, okay, okay. No, this won't do. It's not. We need to get this organized. I can't find any kind of. I don't know why. But there's no section title, dates, homework, classwork. You know, if I said get the notes on remainder theorem, you know, it's going to. You're making it like. You're not going to find. So this won't do. Okay. You need. Next time I check, I want to see something different. Okay. I'll get back to that. I want to check everything first.
No, and because going through.
Yeah. Okay.
It's kind of dating.
Yeah. Okay. That's okay. It's only maths, is it? Everything. Only maths. I don't see your notebook.
They're just like the fact.
Okay, that's good.
No, like
Your homework folder.
Is it?
This is where you do your homework. This is where you do the problem. Oh, good, okay. Right, so this is homework. Okay, fine. No. So fine.
Even the graphics
Long division, yeah. Sure, yeah. Yes, okay. But it's okay to have it. This is yours? Okay, good. Let's have a look for that's yours, okay, so this is your...
What? You know that it's a UK one.
Because we moved to the Quadratic Factors. It's not bad. I was saying that we
What?
and they told me to take this.
You what?
you have other
You wanted to fly with Emirates?
No. The second one.
Yeah. This is math, okay. Only this is math, this part. Okay, that's fine.
It's soon, man.
Same thing.
Yeah. I'm talking to someone from there. Kind of crazy.
Okay, good. All right, so these are all the examples.
She's not nice at all.
Everything is capitalized for math?
Rule 9.
Okay guys, we'll finish there. I know some people have some questions about this one and the homework, I think, from last night. So this will be good to do for the tutorial then, if you want to just mark some questions you want to see in the tutorial, okay? I'm sure there will be something from this lesson you'll want to see and from the lesson last time.
I have a question from the last time.
That's fine as well,
The
yeah.
last.